Hello, good morning, good afternoon, good evening. Welcome to the Bay Area Apache Spark Meetup Group, wherever you're hailing us from. My name is 𝗲𝗂𝗹𝗂𝗀𝗀. I'm the developer advocate working with the developer relations team, focusing on open source products. And joining me today is my esteemed guest, Quentin Lohust. Quentin, you want to say hello to everyone?
Hello, everyone. Thanks, Jules, for the invitation. I'm Quentin from Hugging Face. I'm super happy to be here.
Thank you, thank you. We're going to get started momentarily. Just want to get rid of the logistics sorted out. We're coming to you live on 3 different platforms: X, LinkedIn, and Twitter. So please feel free to put in the chat where you're hailing from, so we have an idea that we have a global community. Because Quentin is in France, I'm in the Bay Area, and we have 2 of our people who are doing the magicians behind it. One in Amsterdam, one in Chicago. So welcome all of you. Before we get started, if you are not a member of the Bay Area Apache Spark Meetup, we urge you that you become a member, so that way you can get up to date about when the next Apache Spark Meetup is coming. The next one is going to be in a month from today, September the 25th or the 27th. We will be posting that on the Bay Area Apache Spark Meetup. We also record those things, and we now have a YouTube channel, so you can actually have a list of all the pre-recordings, so you can share it with people. You can have your playlist, and that way you get an idea of all the meetups that we actually done. Okay, so let's get started. Before we jump into today's material, I'm going to sort of set up the context for what Python data source is all about before I hand it off to Quentin, who's going to talk about how they actually implemented that in the Hugging Face. So let's get started. Let me see if I can slide a little bit about myself. I'm the member of technical staff here with 𝗹𝗶𝗹𝗶𝗃 team, and I've been sort of contributing on off and off basis to Apache Spark and also the 𝗻𝗻flow. I'm also the co-author of the Learning Second Spark edition, and have had the good fortune to work with all the good companies who actually have been on the forefront of leading technologies. So I've been lucky now to be back here at Databricks again. So let's look at what the agenda today is. This is what our agenda is. I'm going to, like I said, kick off today's presentation with a quick overview of what is Python data source, why we actually did it, what is the mission, motivation behind it, and so what. And that will sort of set the context for Quentin, who's going to talk about how they actually use this particular Python data source to take all their Hugging Face data source and convert them. So, you know, we are all familiar endearingly with the Hugging Face data sets, and we use that quite a bit. And then we'll reserve the Q&A for both the presentations towards the end, that way we get the flow going. And yet, excuse me, I'm sort of fighting a sore throat here. So now and then you'll see my voice quivering a little bit. Okay, so let's get into why. What is the Python data source? And I think it's important to remember, before you actually get into any new feature, any new technology, to understand the history, how something came about, what's the evolution, and where we are today, and where we're actually heading in the future. Knowing the past gives you a better grasp of what the present is and what the future holds for us. So here is sort of a 10-year evolution of the Apache Spark data source, right from 2015 to the present time in 2025. And you can see that the first version of the DS1 was released when Apache Spark was in its 1.x release in 2015, almost about 10 years ago. And over a period of a few years, it evolved from DS 1.1 to DS 2.2, where we actually introduced that the preliminary version in 2.1, in 2.3, and then between 2.3 and 3.5, the DSV2 actually improved quite a bit to be more catalog architecture aware and had more advanced features to take advantage of some of the underlying features with the catalog optimizer, and then it culminated today with the introduction of Python data source based on the DSV2 as the next version evolution of the data source. So let's sort of drill down for the next few minutes about each of these and what they hold, and what are the good points, what are the bad points, and why did we actually decide to do the Python data source. So If you look at the DSV1, if you look at the DSV1, and if you double down on it, you'll actually see that it supports all the file-based data sources we actually had initially. It has text. You can use text. You can use Avro. You can use Parquet. The JDBC was a bit limited. It used JDBC connectors to talk to MySQL and all the relational databases. And the stream sources was a bit limited because back, remember, in Spark 1.0, we actually had D streams, and D streams required you to do batch differently from doing from doing streaming. And it was a bit brittle and it wasn't that fault tolerant. And we didn't have Kafka built in. You had to include the external libraries to be able to actually talk to Kafka and do the reading and writing. And then obviously at the time, big data, Hadoop was the prominent stack. So we sort of inherited some of that Hive metastore in HBase and Cassandra as a built-in sources. And there were some shortcomings in DSV1. It was very much RDT based and Spark context. So you had to know a lot about the internals of Spark in order to write the connectors. That added a lot of complexity when you were actually writing that. It didn't have any of the DML support. And some of the API were actually ambiguous. What would happen when you saved something, or when you actually, what would happen when you save as a table? And depending on what your built-in data source is, it would actually give you different results. And they had limited integration with the catalog optimizers. You couldn't do push down predicates, and you couldn't do column pruning and all that. And there was no support, built-in support for both batch and streaming in one workload. So that was, that was the DSV1. If down the line, DS2 came into prominence as Spark was evolving and getting more into the modern data lake architecture. The catalog-based architecture sort of evolved to have that particular interface so people can actually write data sources that worked well with, say, catalog tables like Delta and Iceberg. And so it supported all the features that we actually have today. In addition to JDSB was an external package. And Delta was still an external package, and the Kafka stream was introduced as a built-in data source using a structured stream that gave you both batch and also the streaming process. And one of the important things that was part of this particular process was, if you didn't have a built-in data source that you wanted to actually use it, that wasn't part of it, you were pretty much stuck. So you actually had to implement your ORs. And the DSV2 gave you the classes, the interfaces, the traits that allow you to build your own data source if you actually wanted. And the key interfaces were in Scala and in Java. Like I say, you see that thing in the box, all the catalog was very catalog-based architecture, so it actually worked very well with the modern data architecture. This was a big evolution from DS1 to DSV2. It supported the DLM operations. You could do schema evaluation because that's quite important. And as you know, if you're working with Delta and Iceberg, you can actually do history or version history. You can go back to a particular version of the table. So this was kind of the DSV2 framework that has evolved over the period of 2 years. The problem was that what happened, this is all good, this is fantastic. I can actually write my own built-in data sources, it's very performant. But the problem is that if I'm a Python developer and if I have some data source that I actually want to use and make it part of my PySpark data pipelines, I'm stuck. There's nothing I can do. And out of this, there was a need for us to somehow talk about how we can actually sort of incorporate a Python data source. And we all know the reasons why we decided to sort of include that is, when I talk about we, I'm talking about this community and the Spark team as well. People love Python. People love Python, and PySpark has evolved from 1.x to 4.0 today as a first-class citizen in the Spark executing engine. Most of the APIs are at par with Scala as well, and it's very important. If you've been working in the Python ecosystem, you do pip install of all the packages, all the relevant ecosystem packages that can actually work. It's easy to convenient, it's easy to configure. And it was a simplified version of the Datasets v2 based on Python. There was only one class involved, and we'll get into that. And once you actually have your Python data source, it can seamlessly integrate with your existing transformation pipelines. And there's an underlying sort of Python to Java bridge that allows you to take your Python data source and map it well with the JVM DSV2. And you don't have to worry about all that. That's actually taken care of behind the scenes. So that was the motivation. That was the reason why we actually did that. And it all started with the spit that the Spark team provided or presented to the community to include a Python data source built on top of DSV2 class hierarchy that has one class that you as a Python data implement that, and it supported both batch and streaming read and write. And this was the class that was actually introduced. And if you look at the particular class, it actually is part of the class hierarchy. So you don't have to worry about the JVM interface because that's sort of hidden behind you. All you worry about is the Python interface. And there's only one class involved over here, which is called the data source, which is extended from the JVM version of it, but you don't have to worry about that. All you need to worry about is extend that particular class. Say if you were doing Hugging Face, you will hear about today, or Google Sheets data source you actually want to do, or your own My data source that you want to do, you extend that particular class and you start implementing those very easy public functions, and we look what those are. And the class actually sits in the PySpark SQL data source. It is one file that you actually extend that, and it has both batch processing and stream processing. And you can implement the readers, the writers, and the stream reader and the stream writers. And all your business logic, all the logic that allows you to manipulate, to read, to write, to process all the particular data is implemented in the data source reader, the data source writer. And if you have a streaming version, you can actually do that. And those are only all of the methods that you actually implement along with other ones. So what do those methods look like? If you actually had to drill down on this, this is the primary class. This is the primary framework contract that you as a Python developer would actually implement that. This is the data source. You extend that and you implement these particular public methods. And you only implement those you actually need that you're gonna be using it. So for example, name is typically a string name version of what you might call this data source. You could call it Hugging Face, you can call it REST API, you can call it Python, GitHub, whatever you actually want to call it. That's the name that identifies what the data source is. And the schema is an optional thing. You can either have a built-in schema, which means that every time you specify what your schema is going to be, the reader and the writer will adhere to that particular schema when they're reading stuff from your source and when they're writing stuff to your sink. And the stream reader and stream writer is where you actually put your all the business logic. So that what is the essence of that particular class. Very simple, very Pythonic in many ways. And that's what people love about it. And if you actually go further down to see what your data source reader is, this is the core. This is where you actually write your business logic to read your source and to use the partitions if you actually wanted to take advantage of the distributed nature of Spark. The data source stream reader is again where you actually implement the streaming version of that. And this essentially are the core classes that you actually implement, and that just becomes your Python data source. Very simple, as I said, very Pythonic. Same the case with data source reader. One interesting thing about the data source writer is that you have this additional methods called commit and abort. Those are good informational methods that you implement, that those will be called after your last write batch is written. So this is good for logging and for tracking to see how many of batches were written, where you actually read it. So this is good. If you're interested to find out what batches are written, this is a good way to say, okay, I'm going to write a commit message, so you can communicate that with the application program. I say, these are the commits were written. This can be written to console, or they can be written to a log file. And abort would be called if something actually happened that you might want to close some resources that you want to take care of that. That's a good way to handle any abortion prematurely. And so those are sort of essentially essential methods that sort of define the whole concept of the data source. Now, how do you actually use it? Quite simple, to be honest with you. Once you've implemented all the three, all the public methods that I showed you in the previous 3 slides, There are three simple methods how you actually use it. You create a data source, and that's what I said about implementing all those methods. You extend that from your data source, whether you're writing a REST API data source for your code, or you're writing some Python packages, stuff that you're reading, or you have some proprietary data that's stored in a database, which the JDBC connectors don't support, but you need to write your own, or you have some, proprietary primary file format. Once you've actually created your data source, you implemented all the class method. The second thing is that you register that particular data source, just as you would register a UDF. If you're using UDF in your Python application, you register the UDF. Over here, you register the data source. And this is where you actually provide the name of the extended class. And once you have done that, the third step is that you would just use it regularly, like as you would use your regular built-in data source. So you would read from the data source using the format my data source, and my data source is the name of the string that you provide in your data class name, and you write to the particular data source. Very simple, very Pythonic, very intuitive. And if you have been working with the built-in data source, this just becomes a regular next data source that you actually have. And so that is one of the beauty and one of the powerful features of the Python data source. So just to give you a concrete example, here's one instance where you want to say, write a very simple data source that just emits one row of data frame. And the way you would actually do that is you inherit your data class, inherit your class, or extend your class from simple data source. You provide the name of that, right? And you provide particular schema. In this case, my schema is fixed. And so it's always going to read one int and write one int, or emit one read and one string. And my reader is just returning the handle to the stream reader, which is the one that's going to be executed as a task on the Spark executor. And as you can see, it just yields one line of data, right? I could have batches of data, or I could have rows of data. It just sends one data. And how I use it? Well, in my Python application, I register the data, as I said earlier, and I just start reading, as I would regularly read my built-in pad source. And when I read that and do a show, I get one particular data frame. Very simple, very Pythonic, intuitive to read, intuitive to understand. Let's look at a more concrete example that you might be actually using it. So here's an example that you might actually want to use, say, in generating synthetic data. And synthetic data we all use for various reasons. We might use it for unit testing. We might use it for doing performance benchmarkings. We might use it for testing some new feature that we might want to use it. And you can actually use this particular data source the way it is, and the full implementation of this particular data source in the QR code that you actually see in the upper right corner. You can actually see that, and this gives you the entire full implementation of that. So to have a look at it after the presentation. But the way you write is very simple. You register, as I said earlier, and you do a read format with that particular fake data. Now, because this has a predetermined schema defined, by default is going to return your name, date, zip code, and state, those 4 or 5 columns, because that's what I defined in my schema. However, should you want a different data generated, which is called read on schema, you can actually provide that as part of the API. So when I do spark.read.fake, I can provide the schema here, and I can provide any schema that I want, and the fake now will return you whatever schema on the fly you do that. And this is really a powerful feature, right? And have a look at it, and you can actually use that straight out of the box. So this is one way you can actually see how Python data source comes to fruition, to build your custom data sources, to include that in your data pipelines. So one thing to note is that there are a couple of other things that actually come with this particular data source, which are some of the performance enhancements that come with it. One is that if you have a smaller file, you don't have to use the partitioning. So there's some criteria when to use partitioning and when not to use partitioning. So you don't want to use partitioning when you actually have a small data, right? So by default, there's going to be one partition that your stream reader will read from, and it will read everything in one task into memory. However, If you do have a larger data sets in megabytes and terabytes of data, then you do want to take advantage of the Spark's distributed reading. And that's where the partitioning strategy comes in. And there are two ways you can actually implement partitioning strategies. One is you can do file-based partitioning, where you actually have shards of file, depending on the partition you will have. And then you define the partitions based on the range of partitions, which is the class that we actually provide. And the other way to do that would be to use what I would call start range and end range. And so each partition would actually have the start and stop and start and stop. And so these simple readers will be distributed across your Spark executors, and they'll read each partition and then process the data. And this is one way to do that. So this is one performance enhancement using partition strategy, which is built into it. And you can take advantage of the underlying Spark engine to do your distribution for you. The second bit is that the Python data source supports the 𝗨 data format. And as you know, 𝗨 data format is very valuable, very performant in memory way to exchange data between processes or between JVM and Python processes. And so if your upstream data source has data already in the 𝗨 format, you can return batches of that particular format in your data source reader. And likewise, if your downstream consumer can actually handle 𝗨 batches, then your data source writer can emit batches of that. And this is a huge performance. And as we go forward with 4.1 and 4.2, we'll be actually using columnar format ways, so that all the data actually comes to you is in columns, so you can actually take advantage of this huge performance improvement. And one of the community person who actually implemented called LanceDB, they use 𝗨 batches and columnar format to store all their vector embeddings into LanceDB format, which is now implemented as a Python data source. And those saw a huge performance gain in that. And so the TLDR, people love writing in Python. We are a big supporter in Spark about Python. Spark has emerged from 1.0 to be a second-class citizen to a first-class citizen today. And if you're working in the Python ecosystem, pip install is the way to go. Or if you're using UV Manager or whatever, pip install is at the center of things. It's convenient, easy to configure. This is a very simplified version. If you actually needed to have a proprietary Python data source to include in your Python transformation pipeline, this is actually the way to go. So a couple of points of acknowledgement. This one way to actually get started with this is this two QR codes leads you to two of the Git resources that has very new Python data source APIs and implementation and reference examples that you can actually use to see how they implement it. They include both streaming and bash. They have partition strategies. They use the 𝗨 batches, so that way you have an idea of what to use when, if you actually need for that. So have a go at them and take a look at that. And then finally, a note of acknowledgement to a few people in the community. Alison Wang, who is the member of the Spark open source team, she was the one who led these efforts for that with the SPIP. Hai-Yu Wang was an intern who actually worked with her, and I believe he might have actually worked with you, Quentin as well on the Hugging Dataface. And then generally, as usual, the Apache Spark community who have been invaluable with their contributions. And then today, because of this, these are some of the public community developed Python data source available. And one thing great about the signature data source file and these examples, that if you are doing white coding, and if you actually tell Cursor to say, hey, okay, here, use this particular data source examples that I have, or tell Cloud Code to say, here, you use this as an example, create a data source for me, implement all the methods that allow you for this particular kind of schema that I have, and it will incredibly, at least the first version, generate something that actually you can sort of start playing around with it. So this is actually quite convenient and works very well with the latest and the greatest AI technologies. And with that, do join the community. We really want to hear from you, and hopefully you will implement one of your data sources and let us know when you do that, so we can include in our future presentation. And that with that, I'm going to hand it off to Clinton, who is going to talk about how they actually use this with the Hugging Face datasets. Thank you.
Yeah, Thanks, Jules. Yeah, I'm sure we'll find we'll see more and more data sources for Spark pretty soon, in my opinion. All right. Thanks for the invitation. I'm Quentin, and I'm going to present you the Spark data source for Hugging Face AI datasets that we built together with the Allison's team at Databricks. I'll start. What I will present is first all the challenges that we want to tackle with this data source, all the goals, like the scope of the project. Then I'll present a bit all the steps of the implementation that we went through, how we did the read part, the write part, and also some bonuses, like we actually managed to do a backport of the data source for all the versions of Spark. And then my favorite part, all the optimizations that we did to make the data source really like the fastest IO tool for Spark and Hugging Face datasets. And then I'll just finish like wrapping up all the features and then how to use the data source for Hugging Face datasets. All right, let's start with all the challenges that we want to tackle first to give a bit of context. Challenge number one, accessing 500,000 public datasets on Hugging Face. So yeah, there's a lot of datasets on Hugging Face shared by the AI community. Those datasets are used to train AI models, to evaluate AI models, and much more. And we want to make sure that every single dataset on Hugging Face is super easy to use, right? So that's one very big challenge that we want to tackle. In particular, right now, if you click on any dataset on Hugging Face and you go to its dataset page, so we show some information, right? Like there's a dataset viewer that shows a bit of the data, and there's a button that shows how to use this dataset, and we show a few libraries. And here in this example, we just show like in one line of code, you can use this dataset in pandas, right? So that's the kind of thing we want to do. Challenge number two, accessing really big datasets. Some of the datasets on Hugging Face are huge, and I mean huge, like terabytes of data. Those datasets are generally the ones that are used to pre-train language models, things like that. So they are basically crawled off the web, heavily filtered to get the highest quality text, and to pre-train like the best language models that you can find, right? And those datasets, they are critical for AI, and we want to make sure that it's super easy for anyone to use them. Challenge number three, accessing multimodal data. So there are text datasets on HF, but also a lot of datasets that are made of images, audio, video files, you name it. So here in the example, I'm just showing some of the most critical datasets in web dataset format, which is a format that is made for images and that is optimized for streaming and for data loading. Those datasets are also critical, and we want to make sure that even if they contain multimodal data, and even if they are in a certain data format, we want to make sure that it's also super easy to use them. Challenge number four, accessing private repos. It's possible on HF to have datasets that are private to you, but also datasets that you can share with your team or your organization. And so there's all sort of authentication and collaboration challenges around that. And the last challenge, which is I think also one of the most important, is how to make it easy for people to actually publish AI datasets that then AI engineers can use to train their models and evaluate their models easily, right? So moving from the raw data that is on whatever place they are in to Hugging Face datasets where they are ready for AI and where it's easy to load them in data loaders for AI. to train and evaluate models. So those are all the challenges we want to tackle, and the data source is a pretty good fit for that. So here is a list of all the goals that are linked to those challenges and that the data source has. So first, access any dataset on ℵ in one line of code. That's something that we can do with the data source. Then support all ranges of sizes, modalities, and formats. All ranges of sizes, I mean, that's Spark, what it's meant for, right? Modalities and formats, we have some tools to do that, and we can plug them in the data source. Then enable authentication for private repositories. That's crucial for collaboration. Then publish datasets in one line of code. Perfect for the writer of the data source. And finally, all this must be as efficient as possible. So that's all the goals that we have for the data source for Spark for Hugging Face datasets. Now let's go into the implementation, the fun part. We actually did the implementation in 4 steps. First one, we implemented the read part of the data source with streaming using arrow, etc. But then we implemented writes. Then we did the backports to support all the versions of Spark and not just Spark 4.0. And then my favorite part, the optimizations. We'll talk about 3 optimizations that I love. First one, efficient filtering, then gzet deduping, and finally, parquet content defined chunking. Those concepts are pretty new and they are super interesting. I'm sure you will love it. All right, first step, the read part. So what we did is implement the reader of the data source. I'm just showing part of the code. The 2 main things to note here is in the init parts of the reader. There are 2 important things. The first one is to get the token of the user for authentication. And we use the Hugging Face Hub library to get that. If it's not passed as a parameter, the Hugging Face Hub library can get the token from the CLI associated with the library. And the second point is we are using the Datasets Python package. So Datasets is the name of the package. To check on Hugging Face if the dataset that the user wants to load actually exists, and then load the dataset as a streaming dataset to be passed to the reader that will then take care of yielding the arrow tables. So this is the part of the reader that reads the arrow tables. It iterates on the streaming datasets. And yields arrow tables by batches. And the very important part that also Jules explained is the partitioning. So at Hugging Face, most of the datasets are partitioned. Most of the datasets are in Parquet, and the natural way to partition those datasets is using file-based partitioning. And so that's what we do here. Next step in the implementation, the write parts. So we implement the writer. And this is the class that we implement. And in the what's interesting in the writer here is we use the Parquet writer actually from PyArrow, so that we can write multiple files in a row and just write data until we reach a certain number of bytes and then start a new file. That's it. Pretty simple, and it works well. And then the commit function that at the end, when we are done writing the Parquet files and uploading them, since all the repositories on Hugging Face are actually Git repositories, so there's the notion of commits over there. Then we just do the final commit that we are done uploading the files, and we do a new commit in the dataset repository. The third step of the implementation, the backports. I'm not going to dive too much into this one. The code is open source and you can check it out. Just know that the way we did it is by basically we're implementing all of the main classes related to the data source available in Spark 4. So it's a big try except in the import, and then we're implementing everything. All right, and now my favorite part, optimizations. We did multiple optimizations. So here is the first one, which is only for Parquet datasets. Since the data source is in Python, it cannot really use the catalyst optimizer from Spark. And so if you want to load only a certain part of the data, you need to do it efficiently without the catalyst optimizer. And so how we do it is we allow users to pass their own filters right when they load the data, so that the reader in the data source can only load the columns that the user wants, and also it can also apply filters in advance to skip Parquet files entirely or skip row groups based on the metadata. And so that means you can use the data source with efficient filters. It works. Second optimization. It's about how we made all the uploads to Hugging Face using Spark much faster than to any other cloud storage. At Hugging Face, we have a very specific cloud storage that is using 𝗁𝗏, and that is based on deduplication. The way it works when we upload a file is that it works in 3 steps. First, we chunk the file we want to upload. Then we hash every single chunk of the file. And finally, we only upload the chunks of the files that are unique and that don't already exist on the server, right? So if a file has duplicate data in it, it will only upload the unique data. If part of the data you want to upload already exists somewhere on Hugging Face in some other file, no need to re-upload them, right? So the dedupe really makes uploads much faster, and we managed to integrate that into the data source. So the data source applies this schema directly and doesn't upload the duplicate data. For example, here I just took a Parquet file of 100 megabytes and I added a new column. I re-uploaded the data using the data source. And the actual transfer is not 100 megabytes. It's only the few kilobytes of data that I added, just like that. And last optimization, which is pretty technical and pretty interesting for people who like Parquet and how it is structured internally. This one really is really interesting. So we can actually make Parquet much more efficient when it comes to deduplication by using Parquet content-defined chunking. So the way it works is it optimizes the way the Parquet files are written, so that it's easier to have duplicate data. Because vanilla Parquet, if you have duplicate data, because of all the compression and pages boundaries that are fixed, you can't see them. Like they will be hidden because of compression. But thanks to content-defined chunking, all the pages boundaries are chosen so that duplicate data end up with the same boundaries, and so compression doesn't affect them. We can detect duplicate data, and then we don't need to re-upload them. And so that means here in my example, if we insert some rows, insert a Parquet dataset, and then we re-upload the data, then we don't need, it will only re-upload the new data. Here in my example, it only re-uploads 10% of the data, only what was changed, and that's it. And so that means that when you load the datasets using Spark from Hugging Face, and when you do some edits and you re-upload it to Hugging Face, the upload will be much faster. And it was very easy to do that in the data source. Actually, in the code that you saw, it was pretty transparent because it's already implemented in the Hugging Face Hub library that we use in the data source. So like it required no code. All right, wrapping up with all those features, just to summarize a bit. If we go back to our goals, now we can, thanks to the data source for Hugging Face, we can access any data set on Hugging Face in one line of code. Just use the spark.3.format Hugging Face and then pass the name of the data set you want to load. We support all ranges of sizes, modalities, and formats using partitioning, using the datasets library that does the reading to support formats like web datasets. We support authentication. You can publish datasets in one line of code using the writer. And it's really, really efficient thanks to Arrow, thanks to partitioning, efficient filters, the 𝗏 storage, and 𝗏𝗃 content-defined chunking, which makes it like one of the fastest way to upload the data to any cloud storage. All right, now how you can use it? It's super simple. Just one pip install. You can authenticate using the CLI, then reading one line of code, writing one line of code. And if you want some actual examples, and if you want to check out the code, here are the links to the repository, and then to the documentation with actual code examples, like real world examples. All right, thank you. And I believe now it's question and answers time.
Well, thank you, Quentin. That was a wonderful deep dive into how Hugging Face actually used the Python data source API to make things interesting. One question that popped into my mind while I was looking at your optimization and how you actually are doing the chunking. Now, all the chunking bit is done before you actually upload the Parquet files to the repo from where your data source will actually read it. It's not happening while you're actually reading the Parquet file. So all the optimization for hacks and all that is actually done prior to that to put in the format so that your 𝗨 batches can actually read more efficiently and take advantage of that in the Python data source reader. It's not happening within the Python. You already have that. Is that correct?
Yeah, so you're talking about the upload or the download parts? Sorry, for the filtering or the upload with chunking?
The upload with chunking. So upload with chunking is done prior to
exactly.
you using the Hugging Face data source.
Yeah, because when 𝗨 writes the Parquet file, it writes it in like locally in the temporary directory, and then this file, when we want to start the upload, this file is first chunked using a rolling hash to have boundaries that are robust to duplicate data. All the chunks are hashed, and then it asks the server, okay, do I need to upload this data? And if you don't have to, because it's already there, it does it. That's it.
So most of this data, I mean, if you look at the Hugging Face directories, you see your 50,000 data sets. Some of them are text, some of them are multimodal. So you got images as well as text. How does that actually work? If I had the data that was multimodal and I was using the Python data source to read that, how would it represent when I read the particular data sets using your implemented Python data source? What would the data frame look like? The images are converted into binary format. That's what it looks like. So when I do a _show after I read that for my training data, it would actually show as that, right? It doesn't show. So
there are multiple ways to manipulate images data in data frames. The simplest one is to have like path to your local files or URLs, which is okay in certain cases, but not always the most practical. Then there's another way, at least for AI people that like to manipulate tensors, but no one does that because it just blows the disk away and it uses all your bandwidth. It's really not efficient. And so the best way to do it is just simply to have the bytes of the image files as binary data in Spark, because Spark does have a binary type.
Yes. It is built in, and you can actually read that. Yeah, and images as well. So you can actually read those images. Brilliant. Now, in your I don't know, were you keeping track of how many people are actually using the Python data source to do the reading? So do you actually have like some numbers of the Python downloads for your Hugging Face implementation of PyData source?
It's brand new, so it's pretty low right now. Even
Okay.
like if you check on GitHub, I think the activity just started to go up. So feel free to check the repo, by the way.
Oh yeah,
So yeah,
definitely.
it's brand new.
And those of you who are listening to us, do try it out and let us know, and Quentin and me, to see how you actually do that, because we do want to hear how people are actually using it. It's an important addition to Spark 4.0. This particular feature is quite important. Let me see if it actually has. Go ahead.
Even internally, we've been using Spark a lot, you know, for building AI datasets ourselves. And basically, the data source that we implemented for Hugging Face datasets was also inspired a lot from the use cases that we had internally. And so the team was used to have like this big chunk of code to make efficient reads from Hugging Face into Spark, and now it's just one line. So we have pretty big fans internally already.
Oh, good. Well, that's nice to know. The other question was regarding, forget. I'm trying to see if there's any other questions coming up. I don't see any questions. We actually have a bashful audience, but precisely what exactly internally? Oh, okay, here's the feature. Is this feature to generate synthetic data? Which not this particular feature. The Hugging Face data is actually the actual data, but the feature to generate synthetic data is just a reference implementation of how you can actually use that, right? So if you go to the particular QR code that we actually had, if you joined in later, you can actually look at it, the slides later on, and on the YouTube channel. The reference implementation of generic data is a way for you to just generate generic data for your unit test, for your performance benchmarking, for whatever you actually want to use it. And it's completely implemented as a Python data source. So you can provide during the read time what schema you want, what data it reads, and what data it actually generates. So that's actually a powerful feature, which is different from what Quentin is talking about. Quentin is talking about more about the Hugging Face data sets that we have, over the period of the last few years, have endearingly using it in our PySpark, in our Python, PySpark, whatever you're doing machine learning, you actually normally use that particular data set. So what's next? Yeah, the question actually that came to pop in my mind is, you mentioned something about you had to backport from, did you say 4.03 to 3.0? Why did you think about the backporting? What was the need for that? I'm just curious.
Just make it available right away. I couldn't wait to test it. While we were working on the data source API, it was still in beta, and people wanted to use it right away. So we just implemented it. It was actually pretty easy thanks to one big feature of Spark, that is the map in arrow feature. Because thanks to that, I could re-implement basically all the main features of the data source in Python relatively easily.
Okay, we have a question from a user, Jim Dowling, a good friend of mine, all the way from Ireland, I believe. Hello, Jim. Or maybe you're still in Sweden, you're up in Stockholm. Hugging Face datasets are primarily for training datasets, right? If they are a source, they are used in training pipeline. Who uses PySpark for training pipelines?
No one. No one uses Spark for data loading to train a model. But the thing is, many datasets on HF are really big, especially for pre-training. And in that case, if you want to reuse a dataset that already exists, or if you want to improve one that you made, you want to make it easy to load it in Spark so that you can apply the filters you want, so that you can apply all the formatting function maybe that you want to apply. So that's why Spark is pretty important here for AI datasets.
Yeah, I mean, I can see the pipelines being useful for processing and training the data.
Yeah.
And even then, if you have a data frame that just gives you the training data, if you have a data set that just gives you the test data, you can actually use those data frames to give it to PyTorch as well. So yeah, there are uses of it, but using PySpark for training, yes, nobody does that. Okay, I think we are almost, okay, we got something from Alfredo. I hope not so much. Is it possible to reproduce on a different storage the deduplication approach used? And I'm talking, I think he's talking about the Hugging Face deduplication with hacks. Is there something like an open source layer that can be used on top of S3 and AWS?
Yeah.
Good question.
So the client is actually open source. The storage, like the layer on top of the storage, isn't. But we actually made lots of blog posts on how the 𝗏 team built these storage layers and all the experiments that they went through to optimize all the different parameters for the duplications and stuff. So yeah, there's actually quite a lot of content online that was shared by the 𝗏 team. You should definitely check it out. Pretty interesting.
Yeah, Jen, thanks a lot for clarifying the training data set pipelines. What I meant was that if you actually wanted to take the training data set using the PyTorch, you can actually extract the data frames from each of those columns for different purposes. But yeah, they're not primarily using PySpark for training per se. I think we are a little 5 minutes above time, but I do want to thank Quentin for sharing this great, great Hugging Face data source as an implementation of a reference example for PySpark data source. And I want to thank the community for joining us and all the questions that have. I hope you can actually join us a month from today. We'll be talking about another implementation of how LanceDB actually used the Spark connector. And they were the ones who actually were the first ones to use Python data source, to use multimodal. So hopefully to see you in about a month, and thank you all for joining.
Yeah. Thanks, everyone. Cheers. And if there are more questions, feel free to reach out on Twitter, LinkedIn, whatever.
Okay. Thank you.